So crop rotation. Now this is one of my favorite parts about organic, but especially cool is our background today. So we're at the Wisconsin Integrated Cropping Systems Trial, which is a farm at the University of Wisconsin Research Station. And we're essentially looking at one of the longest running crop rotation studies in the country. We have conventional cropping, we have organic cropping, we have long rotations and short rotations. Everything about how crops interact with each other in a way that benefits the farm is studied here on this place at which we're filming today. Now, the concept of crop rotation isn't new. And it wasn't just thought up by some organic hippies sitting around one day trying to make our lives harder. The benefits of crop rotation have been recognized and celebrated for hundreds of years. Take, for example, this quote from the 1907 Cyclopedia of American Agronomy. "There is no dispute as to the value of crop rotations. Many experiments have reinforced common experience as to the importance of rotation, particularly in recuperating old lands. Folks who farmed before the time of chemical-intensive agriculture know just how important a good rotation is to raising healthy crops and taking care of the soil. The National Organic Program recognizes the foundational importance of crop rotations by making it a requirement for all organic farms. In this module, we'll dive deep into the ins and outs of designing a functional crop rotation for your organic field crops." Let's start by unpacking the term crop rotation. When some folks hear this phrase, they may think of, say, a pie chart where you have each of your little slices moving in the same order over and over again at the same time. Such as corn to soybeans to wheat every single time. But that is rarely what we actually see on organic farms. Instead, when we say crop rotation, we're referring to a strategic, dynamic sequence whose overarching goal is to produce the most healthy and the most profitable combination of crops while building the soil and ultimately managing weeds. Now, the goals of crop rotation in organics are pretty straightforward, and they're really the same goals that you'd see on a conventionally managed operation. With a good rotation, we aim to build soil organic matter, protect the soil from erosion, control weeds, break those pest and disease cycles, provide fertility for cash crops, and maintain profitability and manage those economic risks. How these goals are met is different on every single farm and even in every field. But one thing that all successful organic farmers can agree on is that diversity is important. Longer, more diverse rotations can generally meet each of these goals more effectively than shorter rotations. In practice, experienced organic farmers usually have trusted groups of rotations that they'll try to lump together, ultimately trying to keep the families of different crops spaced out from each other. These clusters help farmers stay adaptable in changing conditions while also keeping diversity in their rotation high. There are so many crop rotations and groupings and sequences that planning a particular rotation can feel kind of daunting. But it's not. You just have to understand what family the crops you want to grow are in and how to schedule them out in a way that makes it so that you don't grow the same family in the same field back to back. To think about it in a little more of a structured way, we've gathered up 6 general principles of crop rotations that will help you get a good start. This list is adapted from the SARE publication, Better Soils for Better Crops. So 1, grow your own fertilizer. Legumes, whether they be forages, pulse crops, cover crops, all bring an incredible amount of nitrogen to the soil for your subsequent nitrogen feeding crops to use. Perform a nutrient budget analysis for the entire rotation to track nutrient inflows and outflows and grow as much of that fertilizer on the farm as you can. 2, follow the nitrogen. Plant heavy nitrogen feeders like corn and wheat in the first year after a legume forage or cover crop to take advantage of the nitrogen while it's at its peak. Wait to plant the light nitrogen feeders like oats until the second or third year after a legume sod or cover crop has been terminated. 3, break up those pest and weed cycles. Most pests and diseases require available host plants to carry out their life cycle. Starve them out by leaving a multi-year gap between certain crop families. Don't follow a crop with a closely related other crop. For example, you wouldn't want to follow wheat just with barley because they're pretty closely related and they're going to have similar pest pressures. If a specific pest pressure is known, deliberately plant a non-host crop for as long as it takes to break the life cycle of that pest. 4, and this one is a winner. Control your dang weeds. Use crop rotation and the characteristics of certain crops to beat back your weeds. Row crops, like corn and soybeans, permit mid-season cultivation, which knocks back certain weed populations. Sod crops, like your alfalfa or your clover, when it's mowed regularly or intensively grazed, help control those annual weeds. Fall-planted cereal grains, like rye, compete really well against a lot of different weeds. Their allelopathic properties inhibit germination of some weed seeds, but you'll want to be careful that one crop doesn't negatively affect another crop. When you plant corn after rye, you may see a little bit of an inhibited germination because of that allelopathic property. 5, supercharge your soil with some livestock. Consider livestock as part of your rotational cropping system. They provide fertility, they provide weed management, and an additional income stream. Even if you just run a hot wire of electric fence around your fields after harvest and have a neighbor bring on some cows, you're gonna realize a great benefit. 6, steward that soil. Grow some crops such as corn or sorghum Sudan grass that leave a significant amount of residue to armor the soil and provide organic matter. Consider the tillage needs of each of the crops and try to figure out how to rotate them so that you don't have big, heavy pockets of tillage, but rather aim for that overall reduction of tillage across the entire rotation. Now, these general principles are a good guide to get started with, but there's one important piece that we haven't looked at yet: context. In organic farming, context is everything. You're working in a dynamic system and each piece reacts to all of the other pieces. Let's take a look at some of the most important bits of context when planning a crop rotation. Your field history. What were the recent crops? What was the tillage history? What weeds do you have present? Field characteristics. Identify the slope, the erodibility, and the water infiltration patterns. The climate. Note the length of the growing season, precipitation patterns and rates, and temperature patterns at the field site. And also your equipment. What field equipment and storage needs do you have available, and how does that interact with crop choices? Markets. Is there a viable market for the crops you want to grow? I can think of a dozen crops I want to grow, I just don't have anywhere to sell them, so they're on my to-do list. Management. Are the skills of the management team a good fit for that crop rotation? And what are your goals? Look to the future. What crops do you want to grow in the future, and how can you practice them now? With all these important details identified, you have what you need to design a crop rotation that will meet your goals. Organic farming is all about continuous improvement. So, as you implement your rotation, track your crop success and your failures. Look for adjustments in your crop groupings that will allow you to improve them. Crop rotation is, and I'm just not exaggerating here, the most important thing we do in organics. It allows us to grow profitable, healthy crops that ultimately work with nature rather than constantly fighting her.